Yes, welcome to my channel. Today we are continuing about the functions of the kidneys, ultrafiltration, indicators, characteristic that help in ultrafiltration. That to separate ultrafiltration. Ultrafiltration is done by the renal tubules. Reabsorption and secretion process and components. Reabsorption. We studied that things are reabsorbed. Reabsorption and secretion process and components. What are the components that is going out through the renal tubule, and what are the substances that are reabsorbed? Difference between glomerular filtrate and urine. Filtrate means that it comes out after filtration. Many things are coming out after filtration. Water is coming out, much salt. Much water and much salts and glucose and protein are coming, but when it is made in the urine, it is concentrated and goes out. The whole of the substances are not passing out. Filtrate is so much, but urine is less only. Much water is absorbed, glucose is absorbed, albumin is absorbed. So there is difference. Quantity will be less for urine. Filtrate coming out will be much. Urine flows from the kidney to the urinary bladder. Urine trickle down into the pelvis. And from there through ureter, it flows into the urinary bladder. And the urinary bladder is kept there temporarily. It is expelled from the expels urethra. Urinary bladder to outside, there is a tube that's called the urethra. Expelled from the urinary bladder after keeping in the urinary bladder for some time, it is expelled. In a few hours, it is expelled. When the urinary bladder is somewhat full, urine is expelled. Washing out disease-causing germs from the urinary tract also takes place during the process of micturition. Micturition meaning passing out of urine. Micturition is the passing out of urine. micturition. Micturition. Passing out of urine. When urine is passed out, the bacteria also washed out. There will be some harmful bacteria which are otherwise likely to cause infection also is washed away. So micturition should take place occasionally, long hours, not conducting micturition. There is a possibility for the bacteria to multiply there. How does avoiding timely urination affect our body? Analyze the description given below. Analyze the healthy habits to be followed. So some people do not urinate due to lack of facilities or laziness or anything. That is not good. It is required to be urinated. Suppose long distance traveling in vehicle, sitting long time without going for urination, it's not good. When only urinated somewhat frequently, there is a possibility for the germs in the urinary tract to go out. To produce 1.5 liters of urine, a man produces about 1.5 liters of urine a day. And for that, it is not 1.5 liters that comes out as the filtrate, so much. The entire blood in the body passes through kidney at least 350 times in 24 hours. 350 times in one day, the entire blood passes. The blood once passes through the kidney, once. Second time, the blood passes through the kidney. Second time, again blood passes through the kidney. Third time, like that, about 150 times it is passing out per day. That is in 24 hours, 150 times the whole blood in the body is passing out. The whole blood in the body is passing out. About 1018 liters of blood is filtered So how much blood is passing through the kidney a day? 1,800 liters of blood is passing. Blood in a person is about 4.5 liters total blood. And through the kidneys, how much it is passing? About 1,018 liters of blood is filtered to form 170 liters of glomerular filtrate. The glomerular filtrate formed is 170 liters. Almost all are absorbed except 1.5 liters, where this 1.5 liters is formed as urine. 1.5 liters only out of 170 liters of glomerular filtrate. Approximately 127 ml of glomerular filtrate is formed in every minute. In 1 minute, how much glomerular filtrate is formed? 127 milliliter of glomerular filtrate is formed every minute. That is, from the glomeruli, 127 ml is flown out every minute. Out of this, about 126 ml is reabsorbed in the blood. 127 liters is gone out every minute. Out of this, 126 ml is reabsorbed to the blood. As a result, 1.5 liters of urine is formed. The urine formed a day is 1.5 liters. 1.5 liters of urine is formed from 170 liters of the glomerular filtrate. One day, 170 liters of glomerular filtrate is filtered. Out of this 170 liters, 1.5 liter urine is formed. Avoiding urination for a long time prevents expulsion of bacteria. So, in some 1 or 2 hours or 2 or 3 hours, urination is to be done. Not don't be without urination very long time. You have understood that urine, the main excretory product, contains water. The main excretory product, metabolic excretory product from the body is urine. The main excretory product contains water, urea, salts. What are the ingredients of urine? Water, urea, and salts are the ingredients of urine. Shall we conduct an experiment to understand the presence of urea in urine? That is, some urine is to be taken and that is to be tested for urea. Conduct the experiment with the help of your teacher and write down the production procedure in your science diary. Plan of experiment. What is the aim? To detect the presence of urea in urine. Materials required. What is required? Sodium hypobromide solution required mainly. Sodium hypobromide solution required. Then some clear lime water also. Take 2 ml of urine in a test tube, 2 ml. A small quantity of urine is taken in a test tube. Take 2 ml of urine in a test tube. Add 4 to 5 drops of sodium hypobromite solution. Sodium hypobromite solution. 4 to 5 drops of sodium hypobromite solution into it using a dropper. So first 2 ml of urine is taken in a test tube. Then 4 to 5 drops of sodium hypobromite solution is added. Observe whether effervescence occurs. Effervescence means foaming and frothing. Foaming and frothing occurs. Foaming and frothing. Observe whether effervescence occurs. Observation. So you will see that there is foaming and frothing. What you see will be there is foaming and frothing. Inference. It shows effervescence of a gas. What could be the gas? The gas could be carbon dioxide. When sodium hypobromate reacts with urea, this is formed. Urea breaks down. When sodium hypobromate reacts with urea, urea breaks down to form carbon dioxide and nitrogen. Carbon dioxide and nitrogen are the gases formed. Carbon dioxide could be detected by passing the gas through lime water. When it is passed through lime water, we will find that there is milky color coming for the clear lime water. When the milky color comes for the clear lime water, we can understand that there is carbon dioxide. Nitrogen gas also will be eliminated. That will be why urea breaks down. Urea breaks down to form carbon dioxide and nitrogen. Urea breaks down to form carbon dioxide and nitrogen. By the way, how is urea formed? It is proteins. The simplest forms of proteins are amino acids. Amino acids, when breaking down to form carbohydrate, ammonia gas is formed. Ammonia gas consists of carbon dioxide and ammonia. So, so ammonia, amino acids. When amino acids break down, ammonia ammonia and carbon dioxide combine together to form urea. Ammonia and carbon dioxide combine together to form urea. So when urea breaks down, what are formed? Ammonia and carbon dioxide are formed. When urea breaks down, ammonia and carbon dioxide are formed. Ammonia will again break down to form carbon dioxide and nitrogen. So once more telling about that, when sodium hypobromite reacts with urea, urea breaks down. Urea breaks down to form carbon dioxide and water. Urea breaks down to form carbon dioxide and water. So inference, we understand that lime water is turned milky. That means carbon dioxide and water are formed. So when carbon dioxide is formed, we can understand that there is urea. So this shows the presence of urea in urine. Then kidneys and maintenance of homeostasis. Homeostasis is the maintenance of the right constitution in the body. Maintenance of the right constitution in the body is called homeostasis. Kidneys play a major role in maintaining the concentration of body fluids. There are body fluids, and maintaining the concentration of body fluids means keeping the body fluids with the right composition. Waste will be eliminated. Waste will be eliminated by the kidneys and maintains right composition. excess water will be eliminated and maintains the right composition. So kidneys play a major role for keeping the homeostasis. Then also they regulate the pH, whether acidic or alkaline is understood through the pH, and there is right pH. The acidity alkaline base is, or the acidity alkaline base kept in the right way. It is called keeping the level of acidity or alkalinity is expressed through pH. So maintains the regulate the pH and the amount of water and salts present in the blood. Amount of water and salts present in the blood. How much dilute, how much water is there, how much salts are there, that is maintained by the kidneys. Analyze how the kidneys maintain homeostasis based on illustration. The inferences you have drawn so far about kidneys and prepare notes in your science theory. Obviously, here given kidneys is functions, expulsion of waste materials, water balance, salt balance, regulation of pH, etc. So maintenance of homeostasis. Waste materials formed as a result of life process. Waste materials are removed. Waste materials which are formed as a result of life process is removed. And disruption of homeostasis does not take place. When the waste materials are removed, right, homeostasis is maintained. Kidney. So that then how? Kidney expel the waste materials, water balance is maintained, salt balance is maintained, and regulation of pH also takes place. Kidneys and maintenance of homeostasis. Then let's study about kidney diseases. Bad health habits, lifestyle and infection. So lifestyle is very important there for the health of kidneys. Bad habits, lifestyle and infection also. Infection by germs. As I already told, when not urinating in time, when not urinating, when the bladder is full, it will cause for the retention of urine, and retention of urine will let the germs not being washed away, and the germs will grow there. Urinary tract infection may lead to kidney infection also. Infection by microorganisms adversely affect the health of the kidneys. Collect more information and conduct seminars on the protection of health of kidneys. You can make seminars and discuss that, and more you study. And diseases given here: nephritis, kidney stone, uremia. Reason: nephritis reason inflammation of the kidneys. The kidneys will become sore, will become reddish. Inflammation of kidneys due to infection or intoxication. Inflammation can be due to infection. Infection means the infection of germs, or it can be due to intoxication also. Intoxication, toxin, intoxication. That means toxins will be poisonous substances. So infection can cause inflammation. Intoxication can also cause inflammation. Then symptoms: turbid means not clear. Turbid and dark colored urine. There will be color. Turbid and dark colored urine. Turbid and dark colored urine in nephritis. Back pain will be there. Where kidneys are in the back, inside, back dorsally. So there will be back pain, lumbago. Back pain, fever. When there is infection, there can be fever. Inflammation also may cause for slight fever. Fever, edema. Edema means swelling of the limbs, swelling, watery fluid swelling. Edema on face and ankle. Face also looks swollen, and ankles also, ankle. Face and angle of the leg especially. Angle of the leg is swollen in the angle of the leg and face also swollen. That should be edema. Water lodged in the intercellular space. Then kidney stone. Deposition of crystals of calcium salts. Mostly it is calcium salts, calcium oxalate, etc. Deposition of calcium salts in kidney or urinary tracts. Calcium salts in the kidney or it can be in the urinary tract. So calcium salts will flow and will get accumulated there. Kidney stone coming, don't think that through food or anything urinary stones reaching there. It is stone is not reaching there. By deposition, just like sedentary rocks are formed in nature. By sediments, deposition of calcium stones, kidney stone is formed. First, a small stone will be formed, they will become bigger and bigger. It can be sometimes in kidney or it can be in the urinary tract. Pain in the lower abdomen. Kidney stone is there, abdominal pain, lower abdomen. It is the lower part of the abdomen the kidneys are. Pain in the lower abdomen, blockage of urine. When in the urinary tract, the stone is there. There will be blockage of urine. Dizziness. When problems comes, there will be dizziness, vomiting, etc. will be there. Then uremia, different types of kidney diseases is called uremia. Uremia, different types of kidney diseases. What are nephritis? The nephrons getting damaged. The glomerulus and getting damaged. Nephritis, diabetes. Diabetes here mainly mean diabetes mellitus. So much glucose in the body, it will make trouble. Glomerulus will get damaged. Diabetes, high blood pressure. Normal pressure is required for the kidneys, every organ. So when the pressure is too much high or low, it will affect the kidneys. Especially high blood pressure will cause for rupture in the minute blood vessels. Then when kidney diseases become severe, excretory substances do not get filtered. Urea, sodium chloride, etc. are to be eliminated from the body. When kidneys are diseased, the proper filtration cannot take place. When kidney diseases become severe, excretory substances do not get filtered out and remain in the blood. Urea-like substances will remain in the blood. So our outside may be clean, environment may be clean, but our internal environment is not clean. We get sick. Our external environment and internal environment should be clean. Our internal environment will get dirty when these urea-like substances get accumulated in the body. So these waste products remain in the blood. How can the lives of those suffering from kidney failure be retained? Very difficult. Kidney failure, urea remains in the blood. How can we save them? How can they be saved? That means by artificial measures, urea will have to be removed. It will have to be removed some osmosis process. So that is what we get artificial kidney. By osmosis, it is removed when passing through some solution through tube. Artificial kidney. The first artificial kidney was designed by the Dutch doctor Willem John Colt. Artificial kidney was first made by Dutch doctor Willem Johan Colt. What is that machine which allows the blood to pass through a solution? That is only, not any other mechanism. Just through osmosis, it is purified. There is the What is illustration? Hemodialysis. Hemo means blood. Hemodialysis. Dialysis done for the blood. In the picture you can see there is the machine and there is a picture. There is dialysis fluid. It is on the hand that connection is given. Blood is passing through the hand, artery, and through the finger. And from here, it is made to pass through a tube. This much our body, finger, hand. And when it is made to pass through tube. Blood is passed. And there will be outside that there will be fluid. It is made to pass through fluid. What is this? This is dialysis fluid. And what is in this? Blood. Blood through a tube is made to pass through, and by osmosis things are removed into the fluid. That is, when blood is passed through a fluid, not directly, not open, it will be in a tube. When blood flows through the dialysis unit, the waste contained in blood diffuse to dialysis fluid. Diffusion takes place. The more materials are urea there, urea will diffuse to the fluid. Urea will diffuse to the fluid. What is diffusion? From a region of higher concentration passing to a urine of lower concentration. In the blood there is more concentration of urea, and outside fluid contains less concentration of urea, less concentration comparatively. So from the fluid, urea will go to there. That is only. It is only through a diffusion. When the diffusion takes place through an semi-permeable membrane, we say it osmosis. Here it is allowed to pass. So just diffusion from a region of higher concentration to a region of lower concentration. Diffusion. Further, excess salts will diffuse into the dialysis fluid because salt concentration is more there. So it is just a diffusion. Waste contained in the blood diffuse to dialysis fluid. Blood to dialysis fluid. Waste materials dissolved. Blood from the artery is connected because from the heart, the blood vessels that take away blood are the arteries. So from an artery, connection is given. From an artery, it passes it through artificial kidney. Blood from the artery with a high quantity of water materials, high quantity of waste materials is passed into the dialysis unit. Heparin is added to prevent clotting of blood. You know that when blood passes out, it will clot. If clotting is done, clotting is taken place, blood cannot then flow out freely. So heparin is an anticoagulant. Heparin is given. Heparin is added to prevent clotting of blood. Purified blood is allowed to pass through veins. Coming back is through veins. This which has gone out. This which has gone out at last will be given connection to vein. From the artery, it goes out through the artery, and through the vein it is made to come back. So from here, from hand it goes, and to hand it comes back. Blood is Passing from the hand to the dialysis unit, and from the dialysis unit it is coming back. Purified blood is allowed to pass through veins. When blood flows through the dialysis unit, the waste contained in blood diffuse into dialysis fluid. The waste will diffuse. Process of diffusion. The waste will diffuse into dialysis fluid. Now next is about a kidney transplantation. That means healthy kidney is transplanted to a person. Is unhealthy kidney is removed. Diseased kidney is removed. When a kidney transplantation is done, just one kidney only is transplanted. Kidney transplantation. Kidney transplantation. Have you heard about kidney transplantation? When does kidney transplantation become necessary? That you know that long time sugar, uncontrolled sugar, and then kidney failure, then dialysis will be done for some time. There is a limit, then dialysis also could be done. Again, the sugar is not controlled, dialysis alone is not enough. Kidney will be getting damaged, and damaged when both the kidneys have got damaged, we'll have to transplant the kidney. When does kidney transplantation become necessary? A single healthy kidney is enough to purify blood. Two kidneys are there, but the other kidney is a stepney. Just one kidney is enough. Just one kidney is enough, but two kidneys are there. A single healthy kidney is enough to purify blood. But when both the will get damaged completely, what can be done? When both the kidneys of an individual get damaged completely, a fully functioning kidney should be received. Fully functioning kidney means a healthy kidney should be received. A fully functioning kidney should be received from a donor to save life. Donor means one who donates, one who gives. One who receives the recipient, kidney recipient and kidney donor. Donor's kidney should be healthy. When kidney is transplanted, during transplantation, damaged kidneys are not removed. Transplantation is done. During transplantation, damaged kidneys are not removed. Means that damaged kidney will be there itself. Instead, what is done? A new kidney is connected below. You can see, look at the figure. Both the kidneys will remain there itself. The damaged kidneys there itself. They are not cut and removed. They are not removed and in that place another one attached not. The old kidneys are there. So when a kidney is transplanted, the person will have 3 kidneys. Below the kidney is attached. Damaged kidneys will be there itself. 2 damaged kidneys. A new kidney is transplanted there. So there will be 3 kidneys, but only one is working. Instead, a new kidney is connected below the non-functional kidneys with the recipient's renal artery. Recipient means one who receives. It is connected to his renal artery. With the recipient's renal artery, new kidney, the kidney that is got from the donor is attached by giving connection to the renal artery with the recipient's renal artery and renal vein. Renal artery and renal vein connected to that. renal artery to supply blood to the new kidney, renal vein to take away the blood from the kidney, new kidney. The ureter of the transplanted kidney is attached to the urinary bladder. Ureter of the transplanted kidney, that is from the pelvis, the ureter starts. That is given to the urinary bladder. And the other things will be there itself. Other two kidneys, its ureter and will be there. So the ureter of the new kidney, the ureter of the transplanted kidney is attached to the urinary bladder of the recipient. Dr. Joseph M. Murray conducted the first kidney transplantation surgery. These some years. Dr. F. Murray conducted the first kidney transplantation surgery. So you can see the figure in your book. Two kidneys are there, yet the another kidney below is attached. And the new kidney that is to be transplanted, the figure is given. And kidney is detached and taken with this renal artery, renal vein and ureter. It is like that, the new kidney is given. A single healthy kidney is enough to purify blood, but when both of the kidneys of an individual get damaged completely, both the kidneys of an individual get damaged completely, a fully functional kidney should be received. Must be healthy kidney, not poorly functioning kidney, not required. Damaged kidney, not required. Fully functioning kidney should be received from a donor to save life. Because if the kidney is not given in time, the person will die in a few days. Kidney of a healthy person who died in an accident is enough. Who died in an accident is enough. Kidney can be taken. Kidney of a healthy person who died in an accident or a completely healthy person also can be. If a completely healthy person is ready to be as the donor, that is enough. Or kidney of a person who died in an accident. Completely healthy person can be transplanted after considering the matching of blood groups and tissues. Matching of blood group is required. Matched group only can be, otherwise it won't. It will be rejected by the body. Blood group should be matching. The matching blood groups and tissues. Tissues also should be matching. Matching blood group and tissues. Collect more information and news excerpts about kidney donation and design a poster including the attitude to be shown towards kidney patients. You have to make a poster such that there will be donors. The attitude of the people should be, you have to consider the attitude of people. You should have the poster such that there should be a good attitude for people to donate kidney to the other. Towards kidney patients, have a good attitude to kidney persons. Kidney persons are to be helped by kidneys are donated to them. Displayed on the bulletin board. Excretion in other organisms we are going to study now. We studied about human kidneys. Then, how are the other organisms excreting? They also have got the waste materials to be removed from the body. Urea, ammonia, uric acid, etc. The nitrogenous waste waters they also have to eliminate because protein in everybody's body, every organism's body, and protein disintegration takes place, and then that is to be eliminated. Analyze illustration 5.8. Complete table 5.2 regarding different types of excretory mechanisms present in other organisms. Page 83 full on that. Excretion in other organisms. Amoeba, a unicellular animal. No specific excretory organs in amoeba. How can there be organ? Single-celled animal. Amoeba. Excess water that reach the cell, etc., are expelled through contractile vacuole. So, contractile vacuole is the organella which conducts the function of excretion. You know the figure of amoeba, there is a round leg shown in the cytoplasm. Excretory materials and water will enter into that vacuole. What is called contractile vacuole. And when amoeba moves, those things will remain there. Amoeba will move away. Through the plasma membrane, it will go out. Amoeba moves away. It is like that the excretion takes place. So excretion is through contractile vacuole. Then insects. Excretory organs are Malpighian tubules. In insects, the excretion takes place through Malpighian tubules. And you please subscribe.